All right, so this is going to be part 2 of lesson 1, okay? And we're going to look at the difference between simple interest and compound interest, okay? Compound interest can be a little bit more interesting for a few different reasons, okay? So for compound interest, the interest reinvested, okay? The interest is reinvested, okay? So the interest is reinvested at regular intervals. Oops. Okay, this means you earn interest on the principal and you also earn interest on the interest, we'll say. Okay. Okay. So that just means you put money in there, you're going to earn interest just like simple interest, but every compounding period, if it's every month or every year, the money that's in the account all earns interest instead of the original amount that you put in, like the original $200 from the last video, right? So if it's $284, you earn interest on $284 instead of the 200 every compounding cycle. Okay, so exact same variables here, but it's a different equation, right? And you can see how this resembles something like the exponential equation. Very, very similar to, it's virtually identical to a growth equation, okay, of a population or whatever, right, from the exponentials unit, right? You can see your little exponent up here, right? You've got your interest or your growth rate, right? You've got your starting amount and the end amount. It's identical, okay? It's just being applied in a different scenario here now, right? So we'll label the variables. So this is going to be the amount, right, at the end of the investment. Okay. The P is still going to be the present value, okay? So that's the difference, is it's not the principal this time, is it's the present value. So it's what after every compounding period is what it's worth, okay? So okay. Okay. I is just going to be the interest, same as before. Okay, but it's per compounding period. Okay, so which will mean more once we actually do some questions down in here. Okay, I'll show you this, what that actually means. Okay, and n is going to be the number of compounding periods. Okay, so let's come down here. We'll take a look at this table, okay? And really the key to these questions is the wording. So you got to be careful when you read the questions, right? Okay, so it's going to tell you the number of years that something is invested for, right? And the number of times that you earn interest is basically what compounded means, right? I'll write that down in here. Okay, it's okay, so it's a number of times that you earn interest, okay? over the 5 years, right? Or 7 years or 15 years or 5 years. Okay, so we'll fill in the table. Okay, and some other notable things that you have to know for this is that there are 52 weeks in a year. Okay, and 365 days. Okay. Right, and obviously 12 months in a year. Okay, so you just got to know a few little basic things here. Okay, so let's take a look at the first one. So 7%, I'm going to come across this way here. 7% compounded for 8 years annually. Okay, that's going to turn into, okay, this is how this works. We're going to go, it's 0. Let me make this smaller. We're going to go 0.07, okay, that's the interest rate, and I'm going to divide it by the number of times that it gets compounded, okay? So in this case, annually means once, so I'm going to divide it by 1, okay? And so your I value is going to be 0.07, okay? And then N is going to be the number of times that it gets compounded, okay? So it's going to be 8 times 1 because it's in there for 8 years, okay? But it only gets compounded once per year, okay? And that's N, so it's equal to 8, okay? Now, semi-annually is the other one of the other words, okay? Or terms that we can use to describe this, okay? So for this question, you're earning 10%, okay? 10%. I'm trying to keep that in this box. Okay, you're earning 10%, which you write as a decimal still, so it's 0.1, okay? And your question is, how many times am I going to compound this? Okay, well, semi-annually means twice per year, so I have to divide 0.1 by 2, right? Because it's twice per year. That's going to turn into 0.05. It's going to be your interest rate or your I value, okay? And so how many times does the compounding happen, or how many times do you earn interest? It's how long it's in there and how many times does it happen per year. Well, it's in there for 7 years and it happens twice per year, so you're going to multiply by 2, so your N value is going to be 14. Okay, now quarterly, we're starting to get the hang of this, okay, but it's important to know the terms here, right? Because that's going to change what ends up happening ultimately to the amount of money that you're going to see at the end of an investment, right? That's where you're earning compounded interest, okay? So your interest rate here is going to be 0.12, okay? Now it's compounded quarterly, okay? So you got to break up the 12% because it's the interest rate for the entire year. Break up the 12% into how many times is it going to happen in the year? Well, this one's 4, right? And so your interest rate is going to be 0.03, right? Okay, so that's your I value. And then how long is it in there? Well, it's in there for 15 years, okay? How many times is it going to be compounded every year? 4. So you multiply by 4. And so you're going to get 60 times you're going to earn interest, okay? This is the it's too high. It looks like it's a part of the other question. This is going to be the number of times you earn interest in a year or over the entire investment. Okay, so it's the number of times you're earning interest over the entire investment. Okay, whereas this here is just how many times it happens in a year. So this is once, this is twice, this is 4 times. Monthly is going to be 12, right? So let's take this one. We're going to go 0.06 and divide it by 12, right? We're going to get 0.005. Okay. Now, how long is it going to be in there? 5 years. Okay? 5 years, and then you're multiplying by how many times is it getting compounded? 12. Okay? Which is going to result in 60. Okay? So, let's take a look at, because these are important, these two columns here are really the trick or the difference, the main difference between these questions versus some of the other, like the simple interest questions, right? Okay, this is the challenge to these questions, is being able to figure out these two variables, which you're going to have to do every time, okay? Process isn't going to really change that much though, right? We're still going to write down on the left side. I'm going to write down the things that I know and the things that I don't know. Okay, so when Sarah was born, her grandfather deposited $5,000 in the bank account for her university education. Okay, the account earns 6.5% compounded monthly. How much will the investment be worth after 18 years? Okay, so let's write down the things that I know. It's presently worth, right from day one, right? It's worth $5,000. So the P value is going to be 5,000. Okay. Now, the interest, and here's where a little bit of work is going to be involved. So the I value, okay, is going to be 6.5%, which I'm going to write as a decimal, okay? So 0.065, okay? Now here's the other catch though. It's compounded monthly, okay? So every month you're going to earn a fraction of the 6.5%. What is the fractional amount? It's 6.5% divided by 12. Okay, which you could type in your calculator. We'll get a number just because it's a little bit easier to do these questions with just numbers and not fractions. Okay, so we're going to take 0.065 and divide it by 12. Okay, that's the amount of interest you're earning per month. So we'll go 0.00541542. Okay, that's your I value. Okay, now N is going to be the number of times that this number happens, okay, over the investment. So it's in there for 18 years. So you're going to take 18. How many times is it going to be compounded? 12. Okay, which is going to equal 216, okay? Now, you have everything you need. Your job is to go to your equation. You want to know how much is this thing going to be worth at the end, right? That's your A value, right? So let's type in A equals P multiplied by 1 plus the interest rate, because it's growing. That's why it's plus. Remember that from exponentials. And it's N. So plug in the information and type it into your calculator, okay? So let's go. A is going to be 5,000, the initial amount, or what it was presently worth at time 0, okay? Or whatever time that you're interested in. And then you're going to go 1 plus 0.00542, okay? Looks like a 6, okay? And then that's to the power of 216, because that's how many times it happens, okay? So now this is just a calculator exercise. So you're going to go 5,000, right? That's going to be multiplied against 1.00542 to the 216, okay? So I have to take care of this piece. This is how this question works. You remember exponentials. I got to take care of this and then multiply by 5,000, okay? So A is going to be equal to 5,000 multiplied by whatever that number comes out to be, right? So I'm going to go 1.00542, okay? And that's going to be raised to the exponent of 216. 3.21. So we come back here. It's going to be multiplied by 3.21. Okay. Then we go back to our calculator, take that answer, multiply it by 5,000. There you go. So the A value is going to be $16,070.28. 68. 68 cents. Okay. All right. So you can see there's a bit of a difference between the way that these questions work, right? Because it's always growing, right? Whereas with a simple interest, you're always just earning interest on the initial amount that you put into the account, right? Whereas this, it's continually growing, right? And so you can see how like continually growing follows something that looks like this. We know what this is. It's an exponential. Right? Well, this is an exponential, right? That's why I'm deciding to group this together, right? Because they go hand in hand, okay? So therefore, by the time that Sarah goes to university, the investment will be worth $16,070.68. Okay? A little bit more interesting. Okay, a few more moving pieces, but it's also more interesting, right? So, let's take this. Okay. So here you're gonna have to make a decision. Okay, so this one's a little bit different. Okay, you're gonna have to make decisions, right? Particularly if you take out a loan for a house, right? And there's different interest rates that are compounded differently over different amounts of time, right? You need to make up your mind as to when you buy the house, which interest plan are you going to go with, right? From different companies. Or in this case, it looks like if it could be compounded differently. There's a whole bunch of different scenarios, maybe where you might pay more under one scenario than the other. So this question, we're going to do both of these, plan A and plan B, and then come up with a conclusion as to which one we should choose. Okay. So we're going to do it the exact same way though. Okay. So let's do, we'll do plan A in red. Everything in plan A will be red. Okay. So let's take a look here. I'm just going to write down, let's read the question. So Dustin plans to invest $500 in a general interest account or something, right? It's GIC for 2 years. Okay. And he has two choice of plans. Plan A is going to be compounded annually. So every year he's just going to earn 6.5%. Okay. And plan B, he's going to earn 6.6%. So a little bit lower of a percentage interest rate, but it's going to be compounded 4 times per year instead of once. Okay, so which plan should Dustin follow is ultimately the question, okay? So write out your knowns and unknowns. So for this particular question, I ultimately want to know how much is each of these going to be worth at the end, right? So I want to know A in both of these scenarios, okay? Because ultimately Dustin's trying to make a decision as to which plan to choose. Is it A or am I going to choose B, right? So A is what I want to know for the amount of money or what it's presently worth, or the principal is going to be 500, right? Okay, and then I is going to be, okay, well, the interest rate is going to be 6.5%, which turns into 0.0675, okay, but it gets compounded annually. So divided by 1, okay, so it's still just going to be 0.0675. Okay. Now, N, how many times does it get compounded? In total is N. He's leaving it in there for 2 years. Okay, so it's 2 years. How many times is it being compounded? Twice, because it's annually. It's times 1, right? Every year. So he's 2. Okay, so let's do the math on this. A is equal to 500 multiplied by the 1 plus 0.675 to the power of 2. So A is going to equal 500. We're going to multiply that by 1.675 1.0675 squared. So let's go to our calculator. It's still going to be 500 multiplied by something here. I don't know what it is yet. Let's go to the calculator. 1.0675 to the exponent 2. So square it. You can square that one. 1.14, let's call it. 1.14. And then take that answer here, multiply by 500. 569.78. Okay, that's under plan A. This is how much money he would have at the end of that under plan A. Okay, so let's take, we'll break this now. Let's do plan B, and we'll do plan B in black. Okay, so for this plan, A is going to equal, again, I don't know. The P value is still going to be 500, okay? But this time the interest value is going to be a little bit interesting, or more interesting, okay, than the last one. So the interest rate is 0.0660, okay? Now, it gets compounded quarterly this time, which means it's happening 4 times in 1 year. Divided by 4. Okay, so we can go to our calculator. Oops. Divide that by 4. Okay, that's going to be our interest rate every time it compounds. Okay, so it's 0.0165. Okay, now, how many times is it going to earn this amount of interest? This is the end value, right? Over the total number of, like the total loan. He's going to earn, it's in there for 2 years, same as the last time, right? But how many times is it going to be compounded at this rate? Well, if it happens 4 times per year and it's in there for 2 years, you're going to multiply by 4. So you should see 8 times it's going to be compounded. So let's go up here, right? Oops. Don't need the brackets the first step. You can, but so it's going to be 1 plus, let me write this, 500, and we're going to multiply that by 1 plus the interest rate is going to be 0.0165, okay, and then I'm going to put it to the power of 8, okay, so A is going to equal 500 multiplied by 1.0165 to the power of 8, right? So A is going to be 500 multiplied by something here, right? So let's go, all right, let's go. I meant to do it on my calculator. We got to go 1.065 1.1.0165, okay, to the exponent of 8, okay, 1.1314 again, okay, as you can see, maybe the number's a little bit different, so you're seeing just a subtle difference in what's going on here, okay, not a huge difference, right, but maybe it's more important to carry more digits here instead, right? This is it's highlighting this. So, and I will see that in my, maybe I shouldn't have rounded the last question, right? 13987, 3987. You're gonna see the difference in the answers here, right? Remember, this number wasn't actually 1.14, right? It was a little bit smaller. Okay, so I can do the math on that. Now I'm going to go 500 times that answer, right? 569.93. Okay, so you can see the difference between these two answers, right? We're talking about cents difference, right? Now, that just all that means is that there's not a whole lot different between the two plans in the way that the money well, there's not a lot of difference between the interest rate, first of all, but also in the way that they're being compounded. Okay, so just this combination of interest rate and the compound rate is not seeing a huge difference between which one should be which, right? Now, so really, like, do you really care about whatever it is, 15 cents or whatever, right? Over 2 years? Probably not. So for Dustin, it's really probably not going to matter, right? So you could say Dustin should choose, or would choose, let's say, would choose plan B if he was worried about 15 cents. Okay. If not, it wouldn't really matter. If not, either plan would suffice. Okay. So hopefully some of the other questions you will see bigger differences between each of them. Okay. But that's basically it. That's compound interest, right? And the way that it works.